Hello, my name is Brent Sydow. I'm an employee with a company called United Power. We are a member-owned co-op, electrical co-op, that provides electricity to people in our service territory. Electricity is generated at what they call a generation station, and electricity, the main forms of generation right now are gas, hydro, and coal-fired plants. At a generation station, electricity ultimately goes through a rotor, and a rotor turns and then goes through an electrical generator. And as the electrical generator is turning, it forms a magnetic field. And then that magnetic field ultimately goes through a transformer that steps up that field to voltage, which is ultimately travels down transmission lines. And that's what's coming in here today, right here. So this actual substation where we're at doesn't generate electricity. It takes that electricity and then steps it down to a form that you'll be able to use. These are transmission lines. And the voltage going through these lines is 115,000 volts. So it comes into a substation, and there's many substations in utilities areas. Substations are generally centrally located where there's a lot of growth, so they don't have to build lines a long ways, and they can distribute it more efficiently. So transmission lines go hundreds of miles, so distribution lines generally are not going that far. So transmission lines are traveling a lot of miles, and they go at a higher voltage because as you travel farther and farther, you lose voltage. So we have to step those voltages up to the voltages I'm talking about, and then we'll step them back down at the distribution level. So in turn, a lot of things can happen out there, out there, and so you got to have equipment that will protect it. Otherwise, if you don't have that, if there is a problem, it'll burn down. So the equipment that you see here, these are protective breakers for it, and then this is kind of a switch yard. So this is the transmission side. And over here. And as I said, the voltage over here is 115,000 volts, and then it goes through what's called a station transformer. This transformer steps that voltage down to 12,470 volts. You start at a high voltage level, so it can travel long distances. Then you step it down to another level where you're still traveling throughout a service territory. And then you got to step it down again, where it ultimately goes into the house. These are the protective devices that go out into our service area that are protecting the lines. And ultimately, these are the lines that you would see out there driving around. You may have seen something like this out on a pole. So this is another transformer, and this is providing the station service for this building here. But this is another transformer which you would see just like on an overhead line out by your house. And this is stepping voltage down to the level that goes into your house, 120 volts to 240 volts. So you'll see that, I guess a couple items that you would see in your house, and you hear of a 110 outlet. Generally the voltage going into your house is going to be 120 or a little over 120 volts. So that's the voltage that's running your TVs, running your computers, stuff like that. And then the 240 volts would be running like your dryer. If you have an electric oven, that's the voltage that those appliances use. These are called breakers, or reclosures is what they're called. These are similar to a breaker in your house. When there's a problem, they open up the line, and then so if there's a problem like an animal or a storm, and a pole gets knocked down by a storm or by somebody that hit a pole, these devices are designed to open the line up. So obviously it doesn't burn down and it doesn't cause more damage. The difference with these and the breakers in your house is that these are smart enough that they'll reclose if the problem clears. So if you've ever noticed been in an outage where your lights go off, then they come back on, and then they go off again and they come back on, that's this device operates. So it opens up, it clears the line, it waits to see if the problem that caused the device to open clears, and if it'll close back in. If it doesn't clear, it'll open up again, and it'll do that 3 times. And if the problem doesn't clear, ultimately it'll stay open, and then we got to go out and find out what caused that to open. So we talked about the overhead transformer. This is another transformer. It's an underground transformer, and this is the backup to the station service to this building. But this is something that you would see out in your neighborhoods if you're living in an area that has underground power lines. And it's doing the exact same thing as the one I told you before. So we have, when I talked about the 12,470 volts coming off of the transformer, each one of the phases, and those are, we call those phases, each one of the phases has 7,200 volts on it. And that's what's going in here, and then it's stepping it down to the 120 volts to 240 volts. This particular substation has all underground going out. So each one of these wires is what we would call a phase. These wires right here, we call those underground primary wires. So each one of those wires are going out, goes into other equipment, and then starts distributing it out into the service area. All distribution systems generally are 3-phase systems. They may have multiple transformers, but they call them 3-phase systems. So each one of these, what we call feeders, are going out into different areas in our service territory. They're all fed from that station transformer right there. So essentially, it's 3 phases coming off the transformer. Goes on what's called a bus. That's the aluminum bus up there that you see. And then off of that bus, there's a feeder that goes out with 3 of those phases. We're in the building that was in the substation yard, and we're going to kind of go over the equipment inside the building. This panel here is the transmission side that we looked at. Like we talked about, there's 115,000 volts in that line. It's monitoring everything in this yard. Basically, the equipment that you see here on this panel is the brains of everything that you saw out there, the protective devices. And so you can see there's a lot of complicated equipment on here. And what it does is it basically senses if there's a problem out on the line. And when we talked about that equipment designed to open up, that's what these things are doing here. They're also monitoring what we call load. So load is all the things that you guys are doing out there, consumers, turning things on and off, and that's what we call load. And so these transformers that you saw out there, they're designed to go to a certain capacity, and if we overload those, then they ultimately can burn up, and then we don't provide good electricity, and so a lot of bad things happen. So we need to monitor those things and make sure that we've got the appropriate transformer, for the appropriate application. Essentially, it's similar to like a ground fault interrupter on your outlet, just at a lot more complicated level. It's doing a lot of different things. It's monitoring a lot of different things that we need to look at, so we can provide efficient launches. This is what we call the distribution panel, and this is monitoring the breakers that you saw out there that we went over the protective devices, and it's essentially doing the same thing. It's just monitoring the distribution. And you can see here with these different meters, these are monitoring the things that we talked about. It monitors voltage, it monitors current, it monitors what we call power factor, a lot of different things that we need to know. We come in here when we do maintenance, when we do substation checks. If we have problems within the substation, we may need to come into the building. If we're doing any switching inside of the substation, we can do all that switching from here, or we can do it from our office, which is what we call what they call SCADA operating, supervisory control data acquisition. And what it does is it allows you to remotely control all those devices that you saw out in the yard. This is the battery room for the building. We talked about the station service transformers out in the yard that provide the electricity. Well, sometimes we lose transmission to our substations, but we still got to maintain keep all the equipment in here energized. So this is the battery backup. So if we do lose the substation transformer, we have the ability to still look at all these devices through SCADA, and this is what's powered in the event of an outage. So these batteries they're wired up to provide 130 volts DC. We talked about the breaker, and we talked about inside the building, the kind of the brains of everything out here. This is a control for one of those breakers, and this is the brains for that. So when we talked about this device opening and closing 3 times, all the things in here are monitoring all that will allow this breaker to do that. This is the panel for the station transformer, and basically what this device does is it regulates the voltage, the output voltage coming in from the transmission line. And we want to regulate this voltage to the voltage that we talked about, the 12,470 volts, which is the phase-to-phase voltage. And then each phase that we talked about that was the 7,200 volts, that's what we want to regulate that voltage at. And that's what this panel does here. We call it an LTC, it's a loaded tap changer. This control, we set it for those parameters and it will regulate that voltage. We can tell if the voltage isn't where we want it. We can tell it here, and then we can also tell from our dispatch center. They are also monitoring this, so if we have problems, we'll come out here, we'll look at this, and see what's wrong.